Hello everyone, my name is Sandeep Singh and our video assignment for today's topic is discrete mathematics. So in discrete mathematics we will look upon introduction to cyclic groups. So what basically cyclic groups and cosets are. Cyclic groups are a fundamental concept in abstraction algebra where the element of a group are generated by a single element through repeated application by a binary operation. This introduction will explore the key properties and the application of cyclic groups. Definition of a cyclic group. Definition: a group G is called cyclic if there exists a G element in G such that element G can be written as a power of small g. Second one is generator. The element small g that generates the entire group capital G is called the generator of the cyclic group. Third one is notation. Cyclic group are often denoted as small g where G is a generator. So what are the properties of cyclic groups? First one is order. The order of a cyclic small group G is the smallest positive integer and such that G power n equal to E, where E is an identity element. Subgroups. Every subgroup of a cyclic group is also a cyclic and is generated by a power of generator. Isomorphism. All cyclic groups of the same order are isomorphic to each other. Generator of cyclic groups. So existence, every cyclic group has at least one generator which is the element that generates the entire group. Uniqueness, the generator of a cyclic group is not unique. There can be multiple generators for a given cyclic group. Third one is complementarity. The generator of cyclic group of order and precisely those elements G for which the greatest common divisor of G and n is 1. Subgroup of cyclic groups. Identification. First one is identification. The subgroup of cyclic group small g are precisely the cyclic group G power k where k divides the order of G. Second one is structure. The subgroup of a cyclic group from a chain with each subgroup being proper subgroup of the next larger one. The third one is index. The index of a subgroup G power k is the cyclic group of small g is the order of the small g divided by the order of G power k. Cosets of cyclic group. First definition: the left coset of a cyclic group capital H of a cyclic group of a group capital G which represent an element of small g in capital G in the set of GH and H in H. Partition: the left coset of cyclic group capital H in a group G. Partition of the group G. Cyclic group. In a cyclic group, the left coset of a group subgroup G power k are the set of G power I. O is less than I, less than O is less than I, and I is less than k. And now we will move to the Lagrange's theorem and cosets. Lagrange's theorem: the order of group subgroup H of a finite group G divides the order of G. Second one is coset. The size of the left coset of the subgroup capital H in a group capital G is equal to the order of capital H. Third one is coset partition. The group capital G is partitioned in the left coset of capital H and the number of the distinct left coset is equal to the order of G divided by the order of H. Now we will move to the coset multiplication and the coset representation. Coset multiplication: the product of two left coset itself left coset G of H and H of H equal to G of H. Coset representation: any element of a group G can be uniquely represented as a product of a coset representative and the element of the subgroup H. Coset algebra: the subgroup of left coset of H in G with the operation of coset multiplication from a group isomorphic to G/H. Now we will move to the application of a cyclic group and coset. First one is cryptography. Cyclic group and their coset are used in a public key cryptography algorithm such as RSA and Diffie-Hellman key exchange. Second one is modular arithmetic. Cyclic group naturally arises in modular arithmetic where the integer modulo n from a cyclic group under addition. And the third one is coding theory. Cyclic group and their coset are used in the construction of linear error correction codes such as Hamming codes and Reed-Solomon codes. Now here is the key and conclusion takeaways. First one is fundamental concept. Cyclic groups are fundamental concept in abstract algebra with numerous applications in the various fields. And the second one is generator and structure. Cyclic groups are generated by a single element and have well-defined structure, subgroup and coset. And third one is important of cosets. Coset of a cyclic groups are crucial in understanding the structure of the properties of this group. So in this video we have seen the cyclic groups and first we have seen introduction to cyclic groups. After that we have look upon to the definition of cyclic groups and the properties of the cyclic groups. Then we saw generators of cyclic groups. Then after we have look upon to the subgroup of cyclic groups and the coset of cyclic groups. Then we have saw the Lagrange's theorem and coset. Then coset multiplication and coset representation. Then we have saw that application of the cyclic group and coset. And the last one we have see the conclusion and the takeaways.